Alright, we're going to take a look here at polynomials. Whoops, wrong thing there. Okay, so here we go. Alright, so the first thing that we want to do is define monomial. And mono means one. So a monomial is one term or one piece of a polynomial. Polynomial, poly means many, so a polynomial is a bunch of monomials put together. So let's see here what a monomial is. A monomial is a number. It can be a variable, or it can be a product of numbers and variables. Product means multiplying numbers and variables together. And what's important is that if the variable has an exponent, the exponent has to be a whole number, which means that it is 0, 1, 2, 3, 4, 5, and you can keep counting that way. It's not going to be a decimal exponent. It's not going to be a fraction. It's not going to be negative. It's going to be 0, 1, 2, 3, 4, 5, etc. Let's look at some examples here of monomials. The number 5, the letter x, negative 7 times x times y, or negative 7xy, that's a monomial. And 0.5 x to the fourth, or 5/10 times x to the fourth. Those are all monomials. Now let's look at some examples of terms that are not monomials. This first term, negative 0.3 x to the negative second, is not a monomial because the exponent is not a whole number. Negative 2 is an integer, but it's not a whole number, so that makes that not a monomial. 4x minus y, well, this time this is not a monomial because it's a difference. We're subtracting. We are not multiplying. Okay, up here you'll see that it says product of numbers and variables. This is a difference, so that's no good. And this last one can be rewritten as 2x to the negative third, and again, that negative 3 means that the exponent on the variable is not a whole number, so that is not a monomial. Anytime you have a variable in the bottom of a fraction, it's not going to be a monomial. Alright, the degree of a monomial. Well, the degree of a monomial is the sum of the exponents of the variables. If I wanted to find the degree of this particular monomial right here, negative 2, a to the second, b to the fourth, I would add 2 and 4, the exponents on the variables, and my degree would be 6. If I look at just the plain old number 4, it's a monomial, but it doesn't have any variables, so the degree is 0. And last but not least, if I look at 8y, well, the exponent on just this singular y is 1, so the degree of that monomial is 1. So the degree of a monomial is the sum of the exponents of the variables. Alright, let's take a look here at what a polynomial is. A polynomial is either just a singular monomial like we've been looking at, or it could be those monomials added or subtracted together. To find the degree of a polynomial, it's the same thing as the degree of the term with the greatest individual degree. That sounds a little bit harder than what it actually is. Let's look at some examples here. Let's say we have the polynomial 4x minus 18x to the fifth. Well, 4x and negative 18x to the fifth, those are our two terms in our polynomial. We can see that the terms are separated by a subtraction sign. And if I wanted to find the degree, I would have to find the term with the greatest degree, which is negative 18x to the fifth. And the degree of that term is 5. So my entire polynomial has a degree of 5. Let's look at this polynomial. There are 3 terms. 1, there's a plus sign. Second term, another plus sign. Third term. The term with the biggest degree is the first term in this case. It has degree 3. 2 plus 1 if I add the exponents. And so the degree is 3. And this last polynomial has 4 terms. See, their terms are separated by addition and subtraction signs. The first term this time again has the greatest degree, and it's 4, so that's the degree of my polynomial. Alright, so we're going to take a look at some possible polynomials, and we're going to put them into categories here. 3x over 8, is that a polynomial? Well, let's see. Let's put it in here and see if it sticks. It did. That is a polynomial. Negative 6y squared minus 7 over 9 times x. You might not think that's a polynomial because there's a fraction for a coefficient, and that's not true. You just can't have fractions as the exponent on a variable. So that's actually a polynomial. Square root of 2, plain old number. It looks funky because of that radical sign, but it's a polynomial. So is 1. So is x over 2. Can't have a fraction or a variable in the bottom of a fraction, but you can have a number like 2. That's fine. Let's see, the square root of x. That is not a polynomial. You cannot take the square root of a variable and have it be a polynomial. Let's find some other ones that aren't polynomials. Oh, there's an x in the bottom of a fraction. No good. There's a negative exponent on a variable. No good. X minus 2, yeah, we can throw that in with polynomials. That's a big old polynomial. Whoops. Right here, this will work. Let's see. 2 over x plus 2. Variables in the bottom of a fraction. No good. Not a polynomial. That is a polynomial. And this is a polynomial as well. So you can see some examples of polynomials and non-polynomials. Standard form of a polynomial, this is when you only have one variable, is whenever the terms are in order from the greatest degree to the least degree. In other words, biggest degree to smallest degree. Descending order. When you write a polynomial in standard form, the coefficient of the very first term, it has a special name. It's called the leading coefficient. Leading coefficient. So let's look at some examples where we have to put some polynomials in standard form and find the leading coefficient. Alright, our first example, we have a polynomial with 1, 2, 3, 4 terms. If I want to put it in standard form, I have to find the degree of each term. So the degree of this first term is 1, second term is 3, the degree of 2 is 0 because it doesn't have a variable, and the degree of this term is 2. Okay, when I put these terms in descending order, it's going to look like this. This is standard form right here. And negative 4, the number right out front, that's called the leading coefficient. Alright, let's look at another polynomial. This one has 3 terms with degree 3, 5, and 1. Standard form would look like that from biggest degree to smallest degree, and the leading coefficient is the number 1, which is invisible right in front of that y to the 5th. So that's standard form. It's not really that big of a deal. It might sound a little more difficult than what it actually is. I'm going to go to the next page here. Remember, if you want to see this longer, you can always pause your video and take a look at it to understand it. Alright, next page here. Some special names of polynomials based on their degree and the number of terms they have. These names will help us classify polynomials. We classify 2 ways, by degree and by the number of terms. So I'll refer to this chart as we do the final 2 examples here. If you want to write that chart down for yourself or download the chart off the internet, you can on my website. I have that chart as part of the notes. So, and also the note sheet follows right along with this video, so you can fill in the examples as we go through. Alright, so we want to classify the polynomials here. Here's our first one, 5x minus 6. I want to know the degree, the number of terms, and the classification. Well, the degree is the degree of the term with the largest degree, which is this one right here, and that degree is 1. There are 2 terms. 5x is a term, and negative 6 is another term. And so if I refer back to my chart, let's do that right here. If the degree is 1, that makes it linear. I'm looking right there. And there are 2 terms. That makes it a binomial. So let's go back. Classify a linear binomial. Degree is 1, number of terms 2. Alright, let's see. We want to get the degree and the number of terms. Well, it looks like the degree is 2. This is already in standard form, as was letter A. Degree is 2. The number of terms is 3. We have y squared, y, and 4. And so our classification would be quadratic, which means degree 2. Trinomial, tri meaning 3 terms. Quadratic trinomial. One more here. The degree, again, we have it in standard form already. That's the way I set this up. Let's see, the degree is 7, so we put 7 right here. The number of terms is 4. 1, 2, 3, 4 terms. And so if you're a 7th degree polynomial, you don't have a special name. You're just 7th degree. And if you have more terms than 3, which makes you a trinomial, in this case we have 4 terms, you don't have a special name either. You're just a polynomial. So this would be considered a 7th degree polynomial if we were to classify it. Remember, you can go ahead and recycle back through the video. You can pause it at any time, fast forward, rewind, whatever you want to do. And there is a note sheet that you can download off the internet or get in class that you can fill out that goes right along with this. Alright, I hope you learned something.